Finding equations of lines, the basics. I want you to recall the point-slope form. If you're given a point, x1, y1, and the slope m, then y minus y1 equals m, and in parentheses, x minus x1. So you're distributing the slope to the x minus x1. This is actually the slope formula without the subscripts on the x and the y, but you multiply by the common denominator on both sides. That's all it is. Point-slope form. Slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. It doesn't matter what order, b plus mx, whatever. The thing times x is the slope. The thing by itself is the y-intercept if you have it solved for y. Standard form, ax plus by equals c, where a and b are both not 0. You can't have them both 0 because then you have 0 equals some number c, and that doesn't have an x or a y, so it's not a line. General form, ax plus by plus c equals 0, where a and b are both not 0 again. Look, I've taught out of books that just use standard or just use general or do both. Okay? So it's a preference. The general form, I think, is more setting up for function use when you get into, a little bit further into algebra and start talking about functions and that kind of thing. So at least that's where it seems to be most of the times that I see it and being set up for and that kind of stuff in books. So let's talk a little bit about the standard and general form for just a minute. The general form, again, ax plus by plus c equals 0. The only difference is the c is moved over. And since it's a variable and it's in a formula, we don't put negative there. Now, if we move it here, which I'm about to do, then it matters because it started as c. We're going to move to the other side. Now it's negative c, the opposite of c. So I'm going to subtract ax so that these things cancel. That's what I'm trying to do here. All right, when they do, by equals negative ax minus c. Then I'm going to divide everything by b so that this divides out. Doesn't cancel, it divides out. Y equals negative ax over b minus c over b. So y equals negative a over bx minus c over b. So if I use y equals mx plus b, this is m and this is little b, right? So in general form, it's always true. The slope is the opposite of a over b. The y-intercept is the opposite of c over b. Always. It's always the case. Standard form, the only difference is equals c instead of plus c equals 0. So we don't have to move it over and get negative c. It's just c on the other side. So subtract ax from both sides, right? So that this cancels. Then we divide everything by b. These divide out. And the difference is when they cancel, they go to 0. Divide out, they go to 1. And then so y equals negative a over bx plus c over b. And then in standard form, the following is always true. The slope is the opposite of a over b, and the y-intercept is c over b. So it doesn't matter if you have 2x plus 3y plus 7 equals 0 in general form, or if you have a different one, you have 4x minus 5y equals 20 in standard form. Okay? Doesn't matter which one you have, how you have it. How do I find the slope? The slope is negative a over b. Well, a here is 2 and b is what? 3. And if we want to, c is 7 on that, but we don't need c. So the slope is negative 2 over 3. So the slope here is negative 2/3 for this line right here. I'm sorry. For this line right here. Okay? What about this one? A is what? A is 4. What is b? B in this case is, don't forget, that's negative 5. The formula has a plus. That means you don't change the sign. A minus means you change the sign. There's no minus in either one of these formulas to start with. I do minus when I move stuff around, but that's because I'm doing algebra to it. And then C here is 20, which we don't need, but I'm just identifying it. So then the slope, again, is still the same thing, negative a over b. So it's going to be negative 4 over negative 5. 2 negatives makes a positive, so it's 4/5. So the slope, that's a terrible M. The slope is 4/5. Right there, okay? So I just want to do a couple of examples of that. So if you ever see something in standard form and you need to know the slope, you can find it really quickly without actually solving for y. But what I did was I solved for y generically here with variables on both these to show you where the m and the b came from. All right? Again, that's a little bit of extra information. You don't have to know that because you can go solve for y. But that's extra work, and I don't know why you would change the form to graph it. If I'm given either one of those, I'm using X and Y intercepts to graph. But if I need the slope, if I'm looking at that standard form and go, I need the slope, I can just do negative A over B and find it. Okay. So here, let's just talk about, again, some ways to attack problems, some techniques to use. If you're given a point and the slope, this is going to be deep, y'all, use the point slope form of a line. I know that's deep. If you're given a point and a slope, plug the slope and the point into the point slope form of a line. All right. If you're given 2 points, what do you can always find with 2 points? The slope. Well, find the slope first, and once you have the slope, guess what? Use the point slope form. With which point do you say? Doesn't matter. You pick whichever point you want. The choice is yours right here. Either point. The choice is yours. Okay? What if you're given X and Y intercepts, or either one? Be sure to put them in point form if they're not already in point form. What I mean is if you're told the x-intercept, if you're told the x-intercept is 4, then put that in 4, 0 form, right? X, 4, Y's 0. Intercept means the other variable is always 0. So if X is 4, Y's got to be 0. There's a point. Now use it with whatever else you're given, and you can have 2 points there, okay? And you can find the slope, do whatever you need to do. If you're given a point and an equation of a line and asked to find the equation of a line that is parallel to the given line, find the slope of the given line, okay? So you're given a point and an equation of a line. So find the slope of this line, use the parallel, which is the same slope, and the given point and plug it into point slope form. What about if it's perpendicular? Find the slope of the given line, find the perpendicular slope, which is the opposite reciprocal. So flip it and change the sign, and use the given point and plug it into point slope form. Okay? So these are all scenarios that you'll see in books and on software and everything else. Then I have this red asterisk all the way through here. For my students, be sure to simplify your line to slope-intercept form, standard form, or general form based on the directions. Again, for my students, if the directions don't tell you which form to use or to put your answer in, then you can choose whichever one. And I should have put slope-intercept, standard, or general. Okay? So slope-intercept or general or standard. Okay? Or standard for my students. For my students, you pick which one if it doesn't tell you. If it tells you, then you better put it in that form, okay? For all the other people out there watching this video, because I know so many people are going to watch it, because they're so excited about math, all right? Be sure to make sure which form your instructor, professor, or teacher prefers if not specified in the directions. Same thing, if the directions tell you what to do, do that. But if they don't tell you, then you need to find out what your teacher says they want you to do. For me and my students, they can put it in any form they want to if I don't tell them which one to do. All right, so let's find some. Here I'm given the slope is 2, and it's through the point 1, 3. Well, guess what? I'm given a slope, and I'm given a point. That's my x1, y1, right? That's my x1, y1, and this is my m. So I'm going to use y minus y1 equals m times x minus x1 every time. And guess what I'm going to do? I'm going to write it down every time because I'm going to be prepared. Right, so when you're graphing lines on a test in algebra and you have all these formulas to remember, probably writing them down every time you do a problem is not going to be enough. You're probably going to need to write them down 5 or 10 times each every day until you take your test. And that may take you 10 minutes. I mean, if you can't give up 10 minutes a day for a test, why are you in school, right? I know that's a kind of a harsh way to say it, but you're in school for a reason, to succeed. Set yourself up for success. And then if you learn to do that in school, you'll be able to do that in life and on your job and everywhere else. Okay? It doesn't mean you'll be perfect, but you learn to get in those habits of setting yourself up for success. Free life lesson from Mr. Guest right there. All right. So y minus y1 equals m times x minus x1. So I have y minus 3 equals m, which is 2, times x minus 1. Okay? Remember, a minus in a formula just means change the sign. So that was a positive 3 becomes negative, positive 1 becomes negative. So now we just simplified it. And here I said write your answer in slope-intercept form. So that is, if we remind ourselves, y equals mx plus b. Okay? Why did I want you to do that? I don't know. Because that's my favorite probably. I don't even know. I don't know if I have a favorite form of a line. I'm just messing. Y minus 3 equals 2x minus 2, right? Distribute. Then we're going to add 3 to both sides because we want y by itself. Y equals 2x plus 1, and that is it. So there, what is m? This is not part of it. M is 2. The slope is 2. What is b? B, little b, the y-intercept, little b is 1 there. And by the way, little b and big B are different, right? Big B is in standard and general form, and it's the coefficient of y. Little b is the y-intercept. Y equals mx plus b. It's not the coefficient of y. So there's an example right there of why capital letters matter in math. Math is what we call case sensitive. All right. I'm old enough to remember passwords on computers that were not. If you did a capital A, you didn't have to do a capital A when you typed it in the next time. It was okay. Nowadays you have to, and they even require it on most things. A capital, lowercase, a symbol, and a number, and at least 8 characters. And it can't be anything to do with you, like your initials or whatever. Right. So slope equals negative 3/5 through the point 10, negative 4. This is exactly the same scenario we just had. The only difference is the slope is a fraction, right? Everybody loves fractions. Everybody say it with me. I love fractions. Nobody said it, did you? No, I know you didn't. Okay. But hopefully you can learn to live with them. All right. This is x1, y1, and the other one is m, right? So guess what? Y minus y1 equals m times x minus x1. There's my formula. Every stinking time I'm writing down my formula. And if you know your slope formula, this is just a slope formula. Drop the 2's off of it, the subscripts, and then multiply both sides by the denominator and just moves over times the m. Okay, it divides out on the other side. So this is going to be y minus a negative 4 is plus 4 equals m is negative 3/5, and then in parentheses x minus 10. Now, when I had this 2 up here that I distribute, I just went down here and wrote the answer down. I didn't do what I call showing the distribution. When I do what I call showing the distribution, I'm going to take and distribute this, but this is how I'm going to write it. Y plus 4 equals negative 3/5 times x minus 3/5 times negative 10. And you don't necessarily have to do the minus and the negative there. You could say, Mr. Guest, I know a negative times a negative is a positive, and put plus 3/5 times 10. In fact, I think I'm going to change it and do that. So you can do that, or you can say, hey, what? A negative times a negative is a positive right here, right? So let's go here and make this a positive and then just put 10, right? Because I've already taken care of the sign. But my point is I'm showing the distribution. Here, I just said, 2 times 1 is 2. But here, 3/5 times 10 is not so simple. I mean, you might say, well, yeah, it is, Mr. Guest. I know that one is. But sometimes they're not as simple as this one. So I like to show the distribution anytime a fraction is involved to lessen my chances of a careless mistake. Okay? So there's second life lesson. I'm going to be efficient, but if carelessness matters, if being specific matters, and it does most of the time in life, then I'm going to do things to help myself not be so careless or not be so inattentive to detail. I want to be attentive to detail, all right, and make sure that I have it down. So here I'm going to multiply this and show my distribution. So y plus 4 equals negative 3/5 x, right? That's just straight across. And look, don't do this. That's wrong. That's bad. You just wrote this. No, it is this. You can write it that way, or you can write it this way. And don't do this either. Because then it looks like, even though the fraction line's not out there, it looks like the x is down here with the 5. Don't do that either. Okay? So, look, I'm nitpicky, but again, that's attention to detail. My advice to you, if you write slanted fractions, don't. What? That's harsh. That's mean. No. Don't. Okay? If your math teacher does, I'm sorry they do that. They probably know when it's okay and when it's not. But as a math teacher myself, I don't think I should use it when I'm teaching students who are learning. Because it appears that the rules change when I use slanted fractions all the time, and they don't change. So I use a horizontal fraction. Everything in the top's in the top, everything in the bottom's in the bottom. And if I do negative 3/5 times x, you will always note when I do it that if you extend my fraction line out, it will cut through the sort of slice through, I say. It will slice through the variable. Okay? That way I know it's got to be high enough, and that's how I grade my papers on my test. If I'm grading your test and you did this, if I extend that out and it doesn't cut the x, I say it's too low. I count off. I know it's harsh, but it's a detail. I want you to pay attention to detail. Say you're writing a report for someone. You do something careless like that, you could confuse them. We don't need to do that, do we? Especially if our job depends on it. Okay? So negative 3/5 x, and then here, I'm going to remind myself that, hey, wait a minute, this 10 is over 1. So those divide out and become a 2 over 1, right? 10 over 5, 10 goes divided by 5 is 2. So then that becomes plus 6, right? 3 times 2, plus 6. Now I have one step left to do here. Subtract my 4 from both sides. So y equals negative 3/5 x plus 2. And there's your equation of your line in slope-intercept form, y equals mx plus b. There, what is the slope, m? It's negative 3/5. What is b, the y-intercept, little b? It is plus 2. Plus 2. All right, so what about through the point 3,5 and the point 815? Well, guess what? This is x1, y1, and x2, y2. And by the way, that's x1, y1, x2, y2 for the slope formula. When I get ready to plug it into y minus y1 equals m times x minus x1, I can choose the other point, the x2, y2, for my x1, y1 in that one. Sounds confusing, but I'll even change color, and hopefully that'll help. All right, and my apologies again if you can't see color. All right, so I try to use them, though, to distinguish some things and show some things. So here, we're going to say m equals y2 minus, I'm not sure what that's supposed to be, minus y1 over x2 minus x1. So we're going to find our slope. Slope's going to be 15 minus 5 over 8 minus 3. It's going to be 10 over 5. Oops. 10 over 5. And it's going to be 2. So the slope is 2. Now here, this is the deal. Don't find the slope and go, oh, I'm done. M equals 2. No, m equals 2 is not an equation of a line. It's the slope, y'all. So now I'm going to come back and go, guess what? I'm going to do y minus y1 equals m times x minus x1. There's my, right? Find the slope. Then I use the point slope form. With which point? Doesn't matter. The way I choose mine, I disregard pluses or minuses, and I add these up. I go 8 and 23. 8's smaller, so I'm going to use this as my x1, y1 in yellow. But notice I relabeled it in yellow. It's not because I called it x1, y1 to start with. You can do that if you want. I used a smaller one. I pick 0. If 0's in it, I pick 0 every time. If both have 0 in it, I pick the one that has 0 for the x. I'm sorry, 0 for the y is the one I pick over x. But it doesn't matter. Those are strategies. That's not math. That's not what you have to do. All right? That's just things that I picked up on and that I use and utilize. You can do it a different way. It's okay. So here, y minus y1, I'm going to call it 5, equals, I'm going to leave a space for m right now, x minus 3. What is my m? My m is 2, right? So I'm going to take this and plug it in here for m. Okay? So 2. And then y minus 5. And here, I don't need to quote unquote show my distribution, right? It equals 2x minus 6. Y equals 2x minus 6. So I have 5. Y equals 2x minus 1. And there's my final answer there. Y equals 2x minus 1. And then I have one where I said, okay, the x-intercept is 4 and the y-intercept is negative 2. So again, x-intercept is 4 means it's 4 comma 0. That's 1 point. And the y-intercept is negative 2 is 0 comma negative 2. So this is going to be x1, y1, x2, y2. And I'm going to find my slope. y2 minus y1 over x2 minus x1. So m equals negative 2 minus 0 over 0 minus 4 is negative 2 over negative 4 is 1/2, right? Negative over negative is positive. 2 over 4 is 1 over 2. So the slope is 1/2, right? So then I say, okay, wait a minute. Let's see. I need to do y minus y1 equals m times x minus, because I have a point and a slope. have a point and a slope. So I'm going to say this is going to be y. And I'm going to pick the one that has y0. I'm going to call this as my x1, y1. I need to do it different, but I could have picked this one. I could have picked this as for the pink here, for the fuchsia, whatever you want to call it, okay? I could have picked that 0, -2, but I'm going to pick 4, 0. So y minus 0 equals 1/2. And some of you say, well, Mr. Guess, if I got a 1/2 for an m, I want to pick my x as 0 so I don't have to distribute the 1/2. You can do that. That's completely fine. All right? X, and maybe I should have done that here just for the sake of doing this, x minus 4. Okay? So y minus 0, that's just y, equals distribute. So I'm going to have 1/2 times x minus 1/2 times 4. Right? So I'm going to remind myself, hey, guess what? This is over 1. So this is going to be y equals 1/2 x, and we're not going to use a slanted fraction, and my fraction line would slice through my x if it kept going, right? And then minus, that becomes a 2 over 1. So then what is 1 times 2? It's 2. So minus 2, and guess what? There's your final answer. There's nothing else you can do to it. There's nothing to move over. That's why I picked y as 0. There was nothing to move over there. But if I had picked x as 0, then I wouldn't have had to distribute the 1/2 times something other than 0. Actually, I would have simplified it to x. I wouldn't even have distributed at all. And I'm going to fix this 2 because I don't like it. Sorry, 2. I didn't like you. All right, it's my handwriting. It's terrible. All right, y equals 1/2 x minus 2. All right, so let's keep seeing. Let's see what we got here. Let's keep working at this and see what we got. That little line came up. That worries me. Through the point -2, -7, parallel to y equals -5x plus 4. So what is the slope of this line right here? The slope is -5, right? mx plus b. So here is a situation where if that had been standard form, we would have used m equals -a over b instead of solving for y. But if you don't remember -a over b, you could have solved for y. Right? But again, I'm trying to help you be more efficient when you see that. All right? So m is that. But I don't want m. I want what? M parallel. Right? The parallel slope is -5. And then the other thing is I have x1, y1. Right, x1, y1. So, y minus, I'm not sure what that's supposed to be. That's not really a minus y1 equals m, and then x minus x1. So we have y minus a -7 is plus 7 equals my slope, which, by the way, this is the slope you use. We found this slope from this line, but then it said parallel, so we go over here and get this one, right? And that's, again, you got to keep track of what's going on in your mind, what you're using, okay? So what this is a multi-step project at work 10 years from now or 15 years from now. You've been given something that requires a whole lot of work, steps and levels to it, and you may have to do something like find the slope first and then plug it into your formula next. And it won't be something so simple as a line. It will be something much more complex. But the idea of thinking from problem to solution is what math and algebra helps you with. All right? So y plus 7 equals m is -5. That's what we use. And by the way, those are the same slope because they're parallel, but you're using the m parallel. And by the way, that's what this means is parallel slope. That's not m sub 11. Equals -5, and then x minus a -2 is plus 2. And now we just distribute -5x, and then -5 times +2 is -10. It's going to be y plus 7. And then we're going to subtract 7 from both sides, and we get y equals -5x minus 17. And there is your final answer for a line that goes through that point, -2, -7, and it's parallel to the line y equals -5x plus 4. So what about through the point -4, 2? So that's going to be my x1, y1. And it's perpendicular this time to this line. So what is the slope of this line right here? So the m equals 1/3. So m perpendicular, right? That's the symbol. That's not an upside down capital T. It's perpendicular. That's what it looks like, right? M perpendicular is flip it 3/1 and change it to what? Negative. And I'm going to simplify in my head. 3/1 is, hey, wait a minute, that's 3. And then change the sign as negative. So the slope perpendicular is -3, and by the way, that's the slope that I'm going to use, right? That's the slope I'm going to use, and I need to demarcate this somehow. Right, there's my kind of line of demarcation, kind of crooked there, but anyway, problem up top, problem in the bottom here. So -3 is my slope, and so the only thing this line gave me was the slope, was this slope, and then found the other one, right? So that line is no longer, that +7 doesn't mean anything. All that matters there is the 1/3 for the slope, and then I change it and flip the sign and right, make it perpendicular, flip it, and change the sign. So then I'm going to use y minus y1 equals m times x minus x1. Okay, so y minus 2 equals m is -3. That's what I use. Don't use the 1/3. -3 times what? X plus 4 minus a -4. Distribute the -3. -3x minus 12, and that equals y minus 2. Then we're going to add 2 to both sides, and we end up with y equals -3x. Wait. -3x minus 10. Y equals -3x minus 10. All right, so through the point 4, -6, parallel to y equals 7. So this is my x1, y1. And then my, wait a minute, parallel to y equals 7. Y equals 7? So I always talk about Vux and Hoy. Hoy means y equals a number, the slope is 0. That really says slope is 0, and it's a horizontal line. So my slope here, my slope is 0. So if I want to be parallel, my parallel slope is also what? 0. Now, what is perpendicular to 0? If you change the sign and flip it, -0 and put 1 over it. What's 1 over -0? Wait a minute. -1 over 0, that's undefined. That's right. That's undefined. So 0 and undefined are perpendicular to each other. Here, parallel, both 0. So if it's also 0, then I already know Hoy fits. It's going to be y equals some number, right? Not hashtag number. So y equals what number? Well, what's my y value here? -6. I mean, that I really want you to identify that and write down y equals -6. If you plug it in your formula, y minus y1 is going to work on this one. It's not going to work on undefined. Y minus +6 equals 0 times x minus 4. 0, when you distribute it, the whole thing is 0. So then you subtract 6 from both sides, and you get y equals -6, which is what we have here. Okay? So that's where it comes from, but you need to identify it because it doesn't work when it's undefined. You can do it when it's 0, but not undefined. Okay? So I just showed you that. I'm going to erase this. You can rewind it and see it if you need to. Right? But you need to identify that's Hoy. Right? So then here, this is x1, y1. Perpendicular to, that's going to be important, y equals 2. So again, this is Hoy because of the y. The y is in Hoy. That's why that's Hoy. That means the slope is 0. Always the middle thing there gives you the slope. 0. So what is perpendicular to 0? Undefined. And undefined is Vux because the u, okay? Undefined slope. And the Vux tells me it's going to be what? X equals a number. So the line is going to be x equals, what is it? X equals what? Yes, x equals -3 because there's your x value. Okay? X equals -3, and that's a vertical line. Doesn't have a y in it. There's nothing to simplify. It's not in standard form or y equals slope-intercept form. It's just, I guess it's technically in standard form. A is 1, B is 0, and C is -3. Okay? So, I shouldn't say I guess it is in standard form that way. All right? But there's your parallel to y equals -7 or perpendicular to y equals 2. The slope is -2/3 through 11, -5. So I've given you some fractional slopes, but they've been nice because when you multiplied them or distributed, it was a whole number. So here, I want to let you be prepared for the other scenario where you could be given or find a slope that is a fraction, and when you distribute it, it's not so friendly. Okay? Again, it's something you're supposed to know how to do, My philosophy is I can test you on knowing lines and graphing lines without including all these fractions. I can test you on fractions earlier or at a different time. Okay? So if I start mixing things up, then I don't know why you missed it. Did you miss it because you don't know how to do fractions? Did you miss it because you can't do a line? Did you miss it because of some other reason? Right? So, but you still need to be able to do that because, again, life is complex. And sometimes math is complex. Algebra is complex. It's hard to do. There's lots of steps. And maybe it's, I say hard to do. We think, oh, it's so hard, but it's because it's so many steps, or it encompasses finding common denominators inside of something else. And we think that's hard, but each individual step is not that bad. Okay? So that's what we need to look at here. This is going to be M. This is going to be X1, Y1. So this actually goes back to the very first way we did this. Y minus Y1 equals M times X minus X1. Okay? So Y minus a negative 5 is plus 5 equals M is negative 2/3. That's pretty ugly too. Negative 2/3, and then X minus 11. So we're going to distribute here. Negative 2/3 X plus, hang on. Yep, plus what? I'm going to put 2/3 times 11. And then I can put my X there times it. So I'm going to show my distribution, okay? And on the other side, I'm going to leave it Y plus 5. So Y plus 5 equals negative 2/3 X, okay? Not going to slant my fraction there. If I do, I'm going to create all kind of issues. So we're not doing that, all right? Remember my advice, if you write slanted fractions, don't. Just don't ever do it again, okay? Then you'll be better for it, all right? So then in your learning, okay, once you know when it's okay and when it's not, that's fine. But if you teach, I would say don't do it either because you're confusing your students most likely. Plus 2 times 11 there is 22. 22 over 3. Oh boy, right? And that doesn't simplify. There's nothing 3 and 11. There's nothing you can do there. That's it. So what am I going to do now? I'm going to subtract 5 from both sides. So Y equals negative 2/3 X. But wait a minute. This is complicated. Okay? That is not just simply, 4 minus 7 is negative 3. Let's go on. No. So we're going to take this, and I'm going to come over here in a thought cloud, in the yellow thought cloud, and I'm going to figure out what that is. Okay? And bring it back. So I'm going to have 22/3 minus 5. What is my LCD? My LCD is what? The only denominator I have is 3. This other one's over 1, right? So then what do I need to multiply by 3 to get 3? Nothing. I already have it. So this, what do I multiply by 1 to get 3? Anytime you have one fraction and a whole number, you always take the whole number times the denominator of the fraction over itself. Always. So 3 over 3. 3 over 3 here to get the LCD. So that's going to then give me, I'm just trying to use all my colors, 22/3 minus, multiply that together is 15. So this is 15/3. And don't cross this out or don't get here and go, oh, wait, that crosses out. No, the whole reason you did it was to make these the same so you could put them together. It's going to be 3, and it's going to be 22 minus 15, which is 7/3. So then we're going to come over here and put 7/3, and it's positive, so we're going to add it. So Y equals negative 2/3 X plus 7/3, and that's actually my final answer. Y equals negative 2/3 X plus 7/3 for Y equals MX plus B form. So something like that, right, may be better off if you put it in standard or in general form or something, okay? But here I ask for it, all these in slope-intercept form. So I hope this helps you in finding equations of lines.